Welcome to educator.com. This lesson is about adding rational numbers. In this lesson, you'll learn about adding rational numbers, such as adding integers, fractions, and decimals. Applications are, for example, to add time or to add distances. Vocabulary for this lesson that you will need to know is the least common multiple, which means the smallest multiple shared by all numbers, or the least common denominator, the smallest denominators that two or more fractions can share. In this case, these two vocabulary words basically mean the same number. For example, 4 and 5 have the common multiple of, 4 can be 4, 8, 12, 16, and then 20. And 5 can be 5, 10, 15, 20. So their least common multiple that they both share is 20. And if they were fractions, denominators, their least common denominator that they would both share would be 20. So in context of fractions, the least common multiple is known as the least common denominator. Let's try adding fractions with unlike denominators. We will need to find common denominators. 3 over 4 plus 2 over 5. So as we just found in the vocabulary, 4 and 5 share a factor of 20. I'm sorry, not a factor, a multiple. Factors are dividing numbers. Multiples are numbers that you multiply up to. So 4 times 5 is 20, so 3 times 5 is 15. 5 times 4 is 20, and 2 times 4 is 8. Now the denominator is the same, so you'll leave it the same, and 15 plus 8 is 23. You may be asked to write your fractions in mixed numbers if necessary. This will go in once with the remainder of 3. So you can think about moving clockwise here, 20 and 1 over 3. Algebraically, often you would leave the number 23 over 20, but you want to ask your teacher which form he or she prefers. Next, negative 3 over 5 plus 1/7. Let's make the denominators the same. Then we have to be careful when we're thinking about the negative versus the positive here. 5 and 7 can both become 35. 5 becomes 35 times 7, so on top we get 21. 7 becomes 35 times 5, so on the bottom we have 5. Now, just like in adding integers, we're going to think about the signs here. They're opposite. When you have opposite signs, that means you're going to subtract. 21 minus 5 is 16. And the 21 is the larger digits, so you're going to take the sign that goes along with it, which is negative over 35. And remember to ask yourself if you can simplify. In this case, you cannot, so your final answer is negative 16 over 35. Let's try adding different forms of rational numbers. Before we were adding fractions, and now we'll try adding fractions to decimals. So in this first problem, let's take 8.75 plus 4 and 1/5. And what we're going to do is change the decimal into a fraction. So I'm going to take this decimal, 8.75. 8 is your whole number out front. And if you remember from the lesson how to change a decimal into a fraction, you're going to take the 75, put it over fraction bar. You have 2 decimal places, so 2 zeros, put a 1 in front. So 2 decimal places represents hundredths, and so we have hundredths here. And you're going to be adding that with 4 and 1/5. Well, 75 over 100 is a very large fraction to work with. So let's see if we can simplify the 75 over 100. I know I could divide by 25 both the top and bottom, so I'm going to have 8, 3 over 4. Good. So that still doesn't give me common denominators. However, I've created a fraction with a smaller denominator. So that should make it easier for me to find the common multiple, which is going to be 20. 4 times 5 gave me 20, so 3 times 5 is 15. Over here, 5 times 4 gives me 20, so 1 times 4 is 4. Now just add the whole numbers. 8 plus 4 is 12, and add the numerators. 15 plus 4 is 19, and keep the denominator the same. And 19 over 20 cannot be simplified, so our answer is 12 19 over 20. Remember in these cases to check your answer. You should be estimating. So 8.75 is about 9, and 4 1/5 is about 4. So 9 plus 4 is 13. And if we look at our answer, yes, it's about 13. So we can be pretty sure that our answer is correct. Let's try 3 5/6 plus 2.75, this time differently by changing the fraction into a decimal. So I'm going to take the 3 5/6 and change it into a decimal. 3 is my whole number out front of the decimal, and I'm going to divide the numerator 5 by 6. It won't go in, so here comes my decimal. 6 will go into 50 8 times, so that's 48. And it will go into 23 times, that's 18. And we'll go into 23 times, that's 18. So it's going to be repeating, 3.83, repeating. We'll just have to treat the 3.83 as a 3.83. So here we have 3.83 plus 2.75. 8, 15, 5, 6. So 6.58. Now in this case, since 3.83 is not exact, it may be better to change the decimal into a fraction so that you could have an exact answer, because the fraction will give you an exact answer. However, sometimes your book is asking for an approximation, and 6.58 would be okay. Let's go back and check our answer. 3 5/6 is about 4, and 2.75 is about 3. 4 plus 3 is about 7, and yes, our answer is about 7. Remember that when you give your answer in a fraction form, it's more likely that your answer will be exact. Whereas in decimals, oftentimes you have repeating decimals, so you would need to estimate, or you have decimals that do not end. So you would have to also estimate or round. So oftentimes giving your answer in a fraction is a more accurate and preferred way. Let's try adding these 3 rational numbers, and I'm going to, since these two are already in fractions, I'm going to take this and change it into a fraction. So negative 4.55. Negative 4 is my whole number out front, and to change 55 into a fraction, I'm going to put 55, 2 decimal places, so 2 zeros and 100. I'm going to divide by 5 here so that I can simplify my fraction to make it easier to work with. 55 divided by 5 is 11, and 100 divided by 5 is 20. So I've created negative 4, 11 over 20. Now let's go back to our fractions. We have negative 7, 2 over 5. A positive and a negative is a negative. Negative 4, we just found here, was 11 over 20. And positive times a negative is a negative. Negative 3 and 3/10. So looking at our denominators here, I see a 5, a 20, and a 10. So right away, the common denominator jumps out at me. I see that they can all be 20. Here, I would want to multiply by 4, and I would get negative 7, 8 over 20. Here, the number stays the same. The denominator already is a 20. And here, I could make 10 into 20 by multiplying by 2. Now let's think back to adding and subtracting integers. When the signs are the same, you're going to add. And in this case, all the signs are the same. They're all negatives, so we're going to add. Let's start off with the whole numbers. 7 plus 3 is 10, plus 4 is 14. You can jump around when you're adding. Remember, the commutative property tells us we do not have to add in order. And in the case of adding 7 plus 3, that's faster because they are pairs, a pair that creates 10. And don't forget that that's all going to be negative, moving in the same direction on the number line. Next, 8 plus 11 is 19, and 19 plus 6 is 25. And we keep the denominator the same. We can't give our answer this way because we have an improper fraction along with a whole number. So it's part improper, part mixed number. So let's simplify this 25 over 20. It'll go in one time with the remainder of 5. So this is your one whole. So let's take that one whole and add it with our other whole numbers. So now we have negative 15 with 5 over 20. And lastly, remember, you need to always check if you can simplify. In this case, I can divide both the numerator and the denominator by 5. So I have negative 15, 1 over 4. Let's remember to go back and estimate. This is about negative 7. This is about negative 5, and this is about negative 3. Negative 7 minus 3 is negative 10, minus 5 is negative 15. And yes, that's very close. So we can be pretty sure that our answer is correct. Negative 15 1/4. Let's try adding rational numbers or fractions in a word problem. Scott exercises for 3/4 of an hour on Monday and 5/6 of an hour on Wednesday. How long did he exercise altogether? So I'm going to be adding 3 over 4 plus 5 over 6. 4 and 6 can both be 12. A lot of times people will think 24 because 4 times 6 is 24. But oftentimes it's easier to choose the lowest common denominator because that means later if you need to simplify, it's going to be a little bit easier because you're starting with a smaller number. 4 times 3 is 12 and 3 times 3 is 9. 6 times 2 is 12, so 5 times 2 is 10. So we can go ahead and add here. 9 plus 10 is 19 and over 12. So it could be 19 over 12's hour, or let's try simplifying so we can find out how many total whole hours there are. Numerator divided by denominator goes in once, so I know he's exercised for at least 1 whole hour with the remainder of 7. So 1 and 7/12 hours Scott has exercised. Remember that in word problems you need to give your unit, and in this case we're talking about hours. Now let's try adding 2 and 1/4, 0.16 and 4 over 5. Since 2 of the numbers are already in fractions, I'm going to change this decimal into a fraction. 16 over the fraction bar, there's 2 decimal places, so 2 zeros, pop a 1 in front. And 2 decimal places means the hundredths, so notice on the bottom I have 100. I know that 16 and 100 share a factor of 4, so I'm going to divide both the top and bottom, the numerator and denominator, by 4. 16 divided by 4 is 4. 100 divided by 4 is 25. So I have 2 and 1/4 plus 4 over 25. Oops. 4 over 25 plus 4 over 5. Okay, the 25 and the 5 would be easy to make into the same denominator. However, I have the 4 that I need to consider. So I believe that we could make them all into 100 here. So let's make this 2. 4 becomes 100 times 25 times 25. So we have 25 over 100. And this one, in fact, we could keep it as the original, 16 over 100. And this would equal times 20, 80 over 100. So we have our whole number 2 here that I'm bringing down. All of the numbers that we were adding were positive, so they're all the same sign, so we can just go ahead and add them. And then now I need to add all the numerators, keeping the denominator the same. 25 plus 16 plus 80. 5 plus 6 is 11. 2 plus 8 is 10, 11, 12, 121. All right, so now I have a situation where I have the improper fraction along with the whole number, so sort of improper along with mixed number. And we need to keep it just in one form. So I'm going to simplify the 121 and 100. It goes in one time exactly, or I'm sorry, it goes in once at the very least, and then we have a remainder of 21. So this is your one whole number. So that let's put that whole number with the other whole numbers, and we get 3 with 21 over 100. A baker is making 3 different types of cookies today. The first recipe asks for 3 1/4 cups of walnuts. The second recipe asks for 5 1/2 cups of peanuts. The last recipe calls for 4 1/4 cups of macadamia nuts. How many cups of nuts is he using today? So that means I'm going to be adding up all of these cups to find the total amount that he'll be putting into his recipes. I'm going to look at the denominator. They can all become 4. And in fact, these 2 already are the correct denominator. This one's going to be 5 times 2 times 2 is 2 over 4. And this one is all set to go. I'm going to add all the whole numbers. 3 plus 5 is 8, plus 4 is 12. And now I'm going to add the numerators. 1 plus 2 is 3, plus 1 is 4. 4 over 4. Well, 4 over 4 we know simplifies to 1. So this equals 1. So now we have 12 plus 1 is 13. So in total, he's going to be using 13 cups. Since this is a word problem, remember to answer your problem with units. And we're talking about 13 cups. Thank you for watching educator.com.